In today's lecture, we are going to discuss about the thumb instruction set of ARM. ARM has two types of instruction sets. One is ARM instruction set and another one is thumb instruction set. It can operate in either ARM mode or in thumb mode. Thumb instruction set, when we see the advantages, all the instructions are exactly 16-bit long to improve code density over other 32-bit architectures. The thumb architecture still uses 32-bit core with 32-bit address space, 32-bit registers, shifters, ALU and memory. It gives long branch range, powerful arithmetic operations, large address space. How does this thumb instruction work? The thumb instruction is a subset of ARM instruction set optimized for code density. Almost every thumb instruction have an ARM instruction equivalent. So an example here was being given. Inline expansion of thumb instruction to ARM instruction. The core needs to know whether it is reading thumb instruction or ARM instruction. Core has two execution state, ARM as well as thumb. So the intimation has to be given whether it is working in ARM mode or in thumb mode. So this is the decompression of this 32-bit. Already we have in ARM mode, we have 32-bit, which is compressed to 16-bit. So this is how the constants was mentioned here. Then the other registers, destination and source registers, and then minor opcodes, major opcodes, and conditional flags. Thumb supports four types of branch instructions. One is an unconditional branch that allows a forward or backward branch up to 2 kilobytes. A conditional branch to allow forward and backward branches of up to 256 bytes. The list of branch instructions is branch. One is conditional, unconditional, and BL and BX. Data processing instructions. Thumb data processing instructions are a subset of ARM data processing instructions. All thumb processing instructions set the conditional codes. And these are the data processing instructions in ARM. We have for add, shift, compare, logical operations, multiply, move, negate, logical here, then subtract with carry, test. All these are data processing instructions under thumb mode. And this is load store register instructions. Even if it is working in thumb mode, it supports load store. That's an load store architecture, and so it supports 8 types of load store register instructions: LDR, LDRB, LDRH, a load single byte, sign half word, store byte, store half word. Thumb supports 4 types of load and store multiple instructions. 2 are designed to support block copy. The other 2 instructions implement a few descending stack and stack pointer used as base register. These are the load store multiple instructions: LDM, push, pop, STM. And this is thumb register usage. In thumb state, we cannot access all registers directly. So registers R0 to R7 can be fully accessed. R8 to R12 only accessible by these instructions. 13, 14 and 15 is stack pointer, linker and program counter, which has limited accessibility. CPSR and SPSR. CPSR only has indirect access and SPSR has no access. ARM, how it works. Thumb internetworking is the name given by the method of linking ARM and thumb code together for both assembly and C++. It handles transition between the two states. To call a thumb routine from an ARM routine, the core has to change state. This state change is shown in T-bit of the CPSR. The BX and BLX branch instructions cause a switch between ARM and thumb state while branching to a routine. And this is the syntax. Then data processing instructions. Data processing instructions manipulate data within registers. They include move instruction, arithmetic instruction, shift logical instructions, compare instructions, and multiply instructions. The thumb data processing instructions are a subset of ARM data processing instructions. And this is a syntax how the instructions are being used. Here is an example which shows the post and pre-processing. And in the case of thumb, when a stack is being used, so as like the previous case, it is pushed and then it is popped back. So the stack for stack operations, the following instructions are there. These are the examples to show how the stack operation takes place and how a subroutine is being executed. Direct functionality of block transfer. And so block of data can also be transferred in the case of ARM, even in thumb instruction mode. And swapping is also possible. Swapping bytes of instructions is also possible. And software interrupt in effect of SWI in a user-defined instruction. It causes an exception trap to the SWI hardware vector, thus causing a change to supervisor mode plus the associated state saving, thus causing SW exception handler to be called. The handler can then examine the command field of the instruction to decide whether operation has been requested. By making use of SW mechanism, an operating system can implement a set of privileged operations which applications running in user mode can request. So this is how an software interrupt is being mentioned, and this is a syntax software interrupt, and the immediate interrupt was also been mentioned. So this is for your assessment, and thank you.